Now let's talk about organizing quantitative data. There are lots of ways to do this depending on the type of data that we have, but for now we're going to concentrate on two different ways, a stemplot and a histogram. For a stemplot, our data is broken up into two different pieces, a stem and a leaf. So sometimes this is also called a stem and leaf plot. The idea is we take each one of our numbers and we split it into two pieces. The stems go in the left column, the leaves go in the right. And so this is easiest to explain with an example. Let's suppose we have these lists of ages for some people in a given room. We want to build a stem plot. Traditionally, the stem is the first one or two digits and the leaf is the last digit. So that's what we're going to do. So we draw a line, we put our stem on the left and our leaf on the right. So like I said, the stem is usually the first digits, and we'll notice the first digits here are all 1, 2, 3, or 4. For the leaves, we then write the second digit. So you'll notice we have 3 number 18s. So to the right of the 1, we're going to write 8 3 times. In addition, we have 2 19s, so we'll also write 2 9s. And that gets us everything that starts with a 1. So let's start with everything with a stem of 2. All of our 20s. We have 20, 21, 23, and 28. So next to the 2 on the right-hand side, we'll write a 0, 1, 3, and 8. We can continue this for our 30s and 40s. So this is a very quick and short way to write all of our data. You'll notice on the left where we had all of our data written out, it's much more long and harder to read. Whereas on the right, it's much more compact and we can see all of our data points very quickly and easily. The first digit being the number on the left and the numbers on the right being all of the second digits that belong to that. Next, we'll look at a histogram. A histogram is essentially a bar graph, but for numerical quantitative data rather than categorical data. And there are a couple of distinctions that make a histogram different than a bar graph. As an example, if all of our numbers ranged from 1 to 100, we wouldn't want a single bar for all the number 1s, all the number 2s, all the number 3s, etc. So instead, we would break them into groups, 1 to 10, and how many numbers are between 1 and 10. 11 to 20, how many numbers are between those? 21 to 30, etc. And that's what we do with a histogram, is first we're going to actually just group the data. And there are a couple of rules for this grouping. So first let me do an example and then we'll talk about the different rules. So here's our grouping. Our categories, our grouping are 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. On the right we have frequency, and frequency is just the count from the bar graph. How many are in that group? So we have 5 numbers between 1 and 10, 6 between 11 and 20, etc. So the couple of rules that we have about this. 1, every number needs to fall into exactly one class. So what that means is this wouldn't work if I had a data point that was 57 because 57 wouldn't be able to go anywhere. In addition, I can't group my classes 1 to 10 and then 10 to 20 because where would the data point 10 go? And the other one is the classes need to be all the same width. That means I can't have 1 to 10 and then 11 to 15. They all need to be able to have the same width. So when we draw the histogram, which like I said, very similar to a bar graph, we'll put these classes on the x-axis and the frequency on the y. And we actually only need to put the first number of all the classes, although I went ahead and wrote 51 to be this next empty class that has 0 things, the one from 51 to 60, and we'll see why in just a minute. So between 1 and 11, I have 5 data points. So between 1 and 11, I'll draw a bar of size 5. And for a bar graph, these bars shouldn't touch, but for a histogram, they should. So between 11 and 20, I have 6. So my next bar will go up to 6. Between 21 and 30, I have 8. Between 31 and 40, I have 3. And then finally, between 41 and 50, I have 1. So a couple of notes about this. One, my histogram is far from perfect. In particular, my bars are not all of the same width, and that's because I just did this by hand. But in general, they should be all the same width along the x-axis. So whenever we're looking at these histograms, which for most of this class we'll be more looking at reading the histograms rather than actually creating them, there are three things that we're looking for. One is just the overall pattern, and what I mean by that is the shape, the center, and the variability. And I'll talk about that more in a second. And then we're also looking for outliers, weird data points that don't seem to fit in with the rest of the data. So let's talk about the overall pattern, what this shape actually means. So there are a couple of core shapes that we'll look at when it comes to these. The first of these is called symmetric, and here's an example of something that's symmetric. The idea of symmetric is that it peaks in the center and it tapers down approximately the same on both sides. True symmetry is really rare, but for the most part we can say things are symmetric as long as it's kind of close enough. We do see the peak right about the center, and it's roughly the same on the right and the left. This one is called skewed right. For skewed right distributions, the peak is on the left, and we have this kind of tail on the right where it takes longer to taper down on the right than on the left. So the peak is on the left and we have a tail on the right. On the other side of that is skewed left, where the peak is on the right and we have this tail on the left. Skewed right and skewed left are definitely the two easiest to mix up. Most people want to refer where the peak is, but the actual skew refers to where the tail is. Skewed left means the tail is on the left. Skewed right, the tail is on the right. We also have uniform. Uniform is where every bar is roughly the same height. In this example, they're all about height 4, but they could be any height. The main thing is uniform has everything about the same height. And for the last named distribution, this one's called bimodal. Bimodals have two peaks, and there needs to be at least one class in between those two peaks. So the two highest bars can't be touching. So that's bimodal. These are absolutely not all of the shapes that could happen, but they are the most common. The other things to look for with a histogram are the center, variability, and outliers, and all of those are going to be discussed soon in videos that will come a little bit later.